Hi, welcome back to the second part. Those are great videos, weren't they? I still haven't watched them, or at least as I record this. So I guess, as usual, we'll do 3 more videos here. Call it a day. See you next week. Hi, Editing Greg here. I'd like to congratulate the next group for having audio that was reasonable. Some of y'all are taking advantage of my very limited skills as an audio engineer. Good job, guys.
Hello everyone, welcome to our presentation today, where me and my teammates are going to give you all a brief introduction into a full-stack framework called Web2Py. Firstly, we'll give you a brief introduction about Web2Py and the history behind it. We will then go over some of the main advantages that Web2Py has going for it. Secondly, we will go over some of the features that make it so powerful and useful. We will then examine some of the specific use cases for this framework, and then go over some of its limitations. Thirdly, we'll talk about how to deploy it and where exactly it can be deployed. We will then cover its scalability and performance factors. Finally, we'll have a brief demo that will show you some of the features that we talked about here today. Now, Web2Py, what exactly is it? Web2Py is an open source, full-stack web application framework. It is written in Python and had its initial release in 2007. It was initially written by Massimo Di Piero, who was an Italian web developer and a data science expert. He was a lecturer and initially developed Web2Py as a teaching tool to help him reduce the tediousness of various web development tasks, with an emphasis that he placed on ease of use and deployment. The design of Web2Py was actually inspired by some other frameworks which you guys might have heard of, such as Ruby on Rails and Django. This is why when looking deeper into the design and the approach of Web2Py, you will notice that some of the design concepts were carried over, such as coding by convention from Ruby on Rails. Now, what are some of the main advantages that Web2Py has? Well, it easily allows for rapid development. What does that mean? It means that developers don't need to build everything from scratch. Things such as user forms can directly be worked off of templates. Web2Py also supports an MVC concept, which essentially means that the programming logic is divided into 3 interconnected elements between the model, view, and the controller. The model is responsible for managing the data of the application and receives user input from the controller. The view renders a representation of the model in a particular format. And finally, the controller responds to user input and performs interactions. Now, with this advantage, it is also developed in Python, which means that it needs minimal external setup. There are binaries that exist for both Windows and Mac, and on Linux, you just need a basic interpreter for Python. Next, let's take a brief look at some of its features, applications, and limitations. One of the most useful features that it has is its Web IDE. Because of the presence of the Web IDE, this means that all development tasks such as development, debugging, testing, maintenance, remote database administration, they can all be performed without third-party tools via the web interface, which actually is also another Web2Py interface. We will show you this and cover this more in the demo that we have shortly. It also comes with a cron. What exactly is a cron? Well, a cron is just a mechanism for running and creating recurrent tasks in the background. And Web2Py has actually improved on it by releasing a master worker scheduler. The scheduler is better than the cron because it allows for more parameters to be defined, and it does a better job at running in the background with a more consistent resource utilization. Now, what are some of the use cases? Like, where exactly can you use this? One of the places where Web2Py stands out is for CRUD. Now, CRUD stands for Create, Remove, Delete, and Edit, which is essentially the 4 main functions to having a persistent storage. And since it's all based in Python, it's very easy to write controllers, and the views are optional because of the support that it has for API-based apps. It also has database abstraction, which supports many SQL and NoSQL providers. In fact, it even offers some support for raw SQL, although, well, due to obvious cases, it's not recommended. It also has another unique case, which is in an event that a user needs to interact with a server by just filling out a form, which is kind of like user forms. It helps by reducing the time it takes for development because you can design it based off a template and you don't need to create, or a web developer doesn't need to create everything from scratch. But now that we talked about its advantages, what are some of its limitations? Well, one of the main limitations that it has is in real-time applications. This is because it uses WebSockets and each connection uses its own thread and the server can support a lot of persistent connections. However, there's a slight way you can mitigate this. You can integrate the Web2Py with a dedicated real-time server using a message queue, and this issue can be mitigated. Now, let's talk about some of the deployment and scalability. As you will see in our demo shortly, it's very easy to actually deploy. For local development and testing, you can pretty much just launch Web2Py as long as you have a binary on Mac and Windows, or you can just, if you have a Python interpreter installed, you can just run it via command line. You can also deploy it on Windows servers, which is IIS, or cloud hosting environments such as EC2, Azure VMs, the Google Cloud Engine, because it has virtual machine images. It even has some support for stuff like Heroku and Google App Engine. Now, with regards to its scalability and performance, as I said previously, because of the one thread per request paradigm, it has a certain issue with real-time applications. This is because while threads are pooled, it does also mean that serving static assets is slower compared to a non-blocking server. And also, it limits the amount of simultaneous users that can be responded to in a real-time system because of the WebSockets. But however, one thing that it does have is caching. And it supports RAM, disk, and memcache-based caching. Memcache-based caching is just caching that has a general-purpose distributed memory caching system. And it really helps with scalability. Next, we'll just go over our brief demo, and we'll see you.
In this demonstration for our presentation demo, we're going to run you through how to start the Web2Py server in order to start your own applications. We're going to run you through how to create your own bare bones Web2Py application, and then we're going to run you through our very small demo for this presentation in order to show you how the code works. So without further ado, let's get started. First, what we want to do is just set up a server IP, a server port. These are all default options, and choose any random password of your own setting to start the server. And then you click on Start Server. Once this is done, we simply look at the My Sites Available. So I already have a bare bones here. I'm going to create another bare bones application, name it bare bones 2, and that's going to allow me to create my new simple application. And now we have our very own bare bones Web2Py application. Over here we have our models, controllers, and views defined. Web2Py follows the MVC paradigm, where everything is defined as models, views, and controllers. So models are where the base of controls for the application are. Controllers allow you to essentially switch back between models and views and fluctuate the control flow between them. And views are your front-end layouts. You can essentially use these to modify as you see fit. Now we're going to go back and show you how our demo goes through. We're going to open our demo site, and we're also going to look at editing our demo site, just to show you how the code runs in the back end of the application itself. So this is what our website looks like. It has a hello from demo greeting, which shows us that the demo page is essentially saying hello, hello world. It shows us the number of times it visited the page, and it has a link to first. We're going to click that. Then we're going to submit a visitor name. Once we do that, we press submit, and we have greetings from the page with our name on it. And it has an option to take us back to index the first page. Now we look around what's really happening underneath it all. Our first priority is looking at the controller itself. So we look at default. We see that default has three functions defined for it: for index, for the first page, and for the second page. So we're going to look at the first page, which is index here, not the first page, but index. So looking at it, we have a session.counter, which essentially counts the number of times you visited the page. Once we set that up, we essentially return a message called hello from the page demo, and we also return the counter session. Now we look at how the front end of the index page looks like. A peeking at the file shows us an extension of the original layout page with the response toolbar. This code is the reason why we see this toolbar over here with design request, response session, DB tables, and DB stats. Next, we have some HTML code. The first one shows the message that it gets from the controller. The second is the number of visits and the counter variable that it gets from the controller as well. The third is a button, custom button, designed to take us to the first URL. So that explains our first default index page. Now we move on to first. And notice that over here, we go from default index and redirect to the page default first. So now we look at visitor name. Let's see what's happening for first. So we look at default's controller again. And we look at the definition for the first page. We see there's a form set up. SQL form is essentially an API that Web2Py offers for very easy, quick form building and form processing. So we see it has a field called visitor name, which states the purpose, and then we see what it requires. It requires a not empty field. This will be an error validation that we'll check later on. So we start by asking if the process has been accepted. Once that has been done, we extract the name, and then we redirect to the second URL page. So let's take a look at that. So once again, I place my name, and I press submit. As per the command, we're taken to the second page. Let's also look at the front end and see what's happening for first. Looking at the first page, we see that it simply has the word form in it. This is a simple representation of the SQL form that we created using the API in our first function defined in default. Let's take a look at what happens in the second. It's simply a greetings page, but what happens for the code in default? We see that it extracts the name that the controller defined. And we see there's an error checking here as well, where we either get the name or we redirect right back to the first, and then we return the said name. Where do we return the said name to? We return that said name to the front end side of the code. Peeking at the second HTML file shows an extension of the layout, and we have greetings along with the name variable right there. We see a button that leads us right back to the index, and that's what allows us to go right back to where it all started. Now, let's do an error checking. So over here, we have defined requires is not empty, which states that our form must stress the field to be filled out. So I am going to not fill anything in the visitor name, and I'm going to simply click submit and see what happens. And we see that there's an error in the form, and we see that the error is in entering a value. So now here we enter our name again, and we press submit, and we see the greetings page again. And that wraps it up for the demo.
And that brings us to the end of our demo and our presentation. Thank you all for listening, and we hope that our presentation on the Web2Py framework and its usefulness and application has taught everyone something new. Thank you.
Hi everyone, this is Group 14 and our technology to evaluate is Redux. So what is Redux? Redux is described as a predictable state container for JavaScript applications. Its main purpose is to help write applications that behave in a consistent manner, that run in various different environments while also being easy to test. It doesn't matter which library we use to build the user interface, whether that be React, Angular, Vue, or many others. Redux is independent of that. A simpler way to look at Redux is that it's a toolkit that reduces the complexity of applications that have many interacting components. It does this through a central hub called a store that handles the state information for a web page and creates an API to change any component state and update the page. In simplest terms, it's to separate state data from logic. When looking at Redux's architecture, there are four main components. There's the view or app, actions, reducers, and a singular store. The reducer is where Redux gets its name, reducer to Redux, because the reducer is where the actual state changing happens. So in Redux, each app's component dispatches an action. An example of this would be to change the name of something on the web page. That action is then run through Reducer, whose job is to handle actions and state changes. Specifically, the Reducer takes the action, updates the component state, and sends that info to the store. The state is then saved in the store, and any component that could be affected by that change is already subscribed to the store and gets that information automatically and reloads. In the example of changing the name of a component on the page, the reducer would have a method that handles the name changing.
Well, this is our demo to show off how Redux works. So over here we have a store, and then over here we have an inventory, and then we can buy things from the store and they go into our inventory. Let's check that out. So let's buy one battle axe. We buy it. Goes from selected up here to our buy panel or item info panel. We buy it, we choose how many, and then there it is now in our inventory. Let's also buy some carrots, maybe a crossbow. Buy 3 of those. Might be vampires. Let's buy some garlic. Nice. All right, let's check out the code. All right, so this is just a high-level overview of the code. So don't worry too much about the individual details. This is just kind of high-level how you use it and what it looks like to use Redux. So first you start off by initializing your store. This has nothing to do with like a store where you buy things from. This is just a word that Redux uses to talk about the thing that holds all of your state, where you store your state. So we have toState, items, and picker. All right, this is also where we put our reducers. Our reducers come from these files. Let's check those out. So we go into item slice. A slice is just a word that Redux uses in their Redux toolkit to just mean like a collection of functionality related to a single state. So here we have 2 actions associated with this state. These are called reducers. And so we have our buy reducer and our sell reducer. So it's easy to see what those do after having seen our app. So this one just like kind of takes the item as a payload, and and lets you buy it. So yeah, plus equals the amount you want to buy. This one's minus equals, but not if you don't have any to sell. Another important thing here in the slice is the initial state. So yeah, the initial state is just what the state starts out as. So in this case, it's a big list of items. So we take our items from our JSON, and then map it into JavaScript objects with you owning none of them. All right. So our other reducer is our other set of reducers is the pickers. So the pickers are just like so the picking the items from the store, having them show up at the top, and then buying them from that panel. So it just basically just tells the index of the store that was picked, and then when that the state of the picker changes, the item info knows to re-render and then display the index of the item that we've saved to this state here. All right, let's check out the usage code. Item grid. So that's just like the grid of the items that are in your inventory. It just it basically just maps them out and produces either maps them out based on how many you have. If you have 0, it doesn't show anything. So the only influence this has over the state is the picking. You can't change how many items you have from this spot. So the important things here are the selector. So this basically lets you find things in the state, and then you use it in items. So as you can see, items, and then we map those. And then the important thing is that when the item state changes, it triggers a re-render in this component. And then dispatch is what we use to call state changes. So dispatch pick inventory is the pick inventory, and we pass the index of the thing we're picking. Then that gets sent over to item info. Item info is the thing at the top that either is a buy or a sell, depending on where it is. It's they're both the same component. And then then it updates the it updates the state and executes the buy command. That's what this is here. So that's just a kind of a quick high-level overview without going too deep into the code. But we're going to check out one more thing to kind of see even more how it works. So let's go back to our browser. Here's our app with all the things we bought. And we reload the page just to reset all the states. There's no back end to this, so none of that's saved. It's just it's really front-end experience. All right, so this is just like the regular React DevTools profile over there. But if we go over to the Redux DevTools, we can actually see the change in states as they happen. So let's do a picker. So we go and pick the battle axe. Okay, so we can see that this change of state happens here. So it's picker.pick store, right? In the store, we pick the item in the store. And then the state that changes is the index of the picker was set to 0, which is the index of the ID of the apple, and it changes to 2, which is the ID of the battle axe, and then that's open here. Okay, now we increase how many of those we want to buy for 120 gold. Yeah, we can afford that. Let's buy it. So we just bought 4 battle axes, and so we can see that here. The state changed. It went from, if we hit down, we can see it went the amount we own went from 0 to 4, and then that triggered a re-render in the inventory, which now had that battle axe show up in our inventory. And then, as you can see, if we pick a bunch of things from the store, you can see those events kind of show up, and then we can kind of go through that in time. So we can see here, we can see that changing from 2 to 4, 4 to 5, 5 to 6, and 6 to 7, just like that. Let's buy some of those. All right, cool. And then we can see now some inventory pick events, or not events, state changes, and yeah, and there they are. So this kind of helps visualize the state of your app, see how it's changing, and debug things really nicely. Yeah.
In what situations should Redux be used? Redux should be used when you have large amounts of application states that are needed in many places in the application, so that you don't have to constantly pass props down. Redux can also be used when the application state needs to be updated frequently, or if the logic to update that state is complex. Redux is mainly suitable for medium to large size code base, or projects where you might have to work with many people. This is because Redux requires a fair bit of extra code, but it is helpful for providing infrastructure. Redux should also be used in situations where you need to visualize and see how states are being updated over time. This is an example where Redux should be used. In React, each of the red highlighted boxes is a component. React states are stored locally within each component. In React, states must be passed down through the use of props in order to share states with other components. Looking at this website, we see that the selection on the left side toolbar affects which video is played in the video component and which comments are shown in the discussion thread. These components need to communicate with each other, and their states may need to be changed based on the states of other components. So in this situation, it's better to use Redux with React, because Redux allows the states of all components to be stored in one place. Storing all the states in one centralized area is beneficial, as this eliminates having to pass down props, which can make the overall code very messy. There are many advantages in using Redux. Redux state containers are predictable, and we can expect applications that use Redux to behave consistently across different environments. Redux offers a central store in which any component can access any state from the store. There's no need to pass props back and forth. Having a centralized store for the application's states and logic allows state persistence of a component, and it enables powerful capabilities such as redo and undo. With Redux, testing will be easy since the UI layer and data management are separated. Redux is flexible since it works with any UI layer and has a large ecosystem of add-ons to fit your needs. Apart from the advantages, there are also disadvantages in using Redux. Redux makes you write a lot of boilerplate code, which restricts its design. In Redux, the state is immutable. The reducer updates this state by returning a new state every time, which can cause excessive use of memory. Since Redux doesn't support encapsulation, any component is able to access the data, which may create security issues.
Redux was originally created by Dan Abramov, with collaboration from Andrew Clark. Originally, Dan was interested in the capability of changing past and future states. What this means is, in the example of Mario, the original trajectory is shown. Then, we go back into the past after the game and change the code. This then leads to a change into the trajectory of the character, meaning that something that has already happened had occurred, but it also gives the possibility to envision what would have happened if the code were different. Dan was curious about this possibility, especially in relation to flux, regarding actions. He contemplated how to separate the data from the logic so that you can hot reload the logic and reapply the same actions to the top, moving the problem into a different state. Initially, Dan tried to implement this functionality as a Flux hot reloader, similar to a React hot loader, but realized that it was hard to do because the state has to capture the local variables. However, there is no access to such a thing, so you cannot transplant it when you change a module. Therefore, it is impossible to place it into a new version as well. The solution to this problem was to separate the state from the logic. This is the birth of Redux. It was initially an attempt to make a proof of concept where the logic could be changed, allowing for time travel. The overarching main goal was reapplying future actions on code changes. Andrew, the author of the Flux implementation Flummox, helped to create the Redux ecosystem of tools, create a proper coherent API, as well as extension points like middleware and store enhancers. Redux is not dead yet. The biggest question to answer about the future of Redux is whether Redux can be considered dead. In short, no. According to statistics, as of 2019, roughly 50 to 55% of React applications use Redux. That is a significant percentage. Even considering the percentage alone, transitioning from Redux to something else will take a significant amount of time and resources. For these applications specifically, and for future applications, Redux cannot be considered dead, especially considering its possibility. Matter of fact, Redux is still being used by popular projects and is still being maintained. Yet another reason why we cannot consider Redux dead. The role of Redux in the future always considers other frameworks that can be used. Yes, there will always be alternatives, but that is true for anything. And also yes, there are cases where Redux might not be used. And again, this is true for everything. In all situations, there are cases where a specific tool may not be used, and for that reason, the non-usage of Redux should not be considered an issue. Even at the beginning, Dan and the other Redux maintainers have said that one might not need Redux. In all cases where another framework may replace Redux, it is irrelevant because Redux will always have a set purpose. Yes, there may be new frameworks, but Redux will always have its special features, and therefore can always be used in the future. Redux will always be a solid choice as it provides consistent architectural patterns, debugging capabilities, middleware, add-on and extensibility, cross-platform and cross-framework usage, and depending on your app setup, better performance than just context. Not only that, in December of 2020, the alpha version of RTK Query, which is an experimental data fetching and caching library built for the Redux toolkit, was published. As you can see, this is another example of why Redux is not going anywhere anytime soon. To wrap things up, Redux is helpful for giving structure and managing large JavaScript applications. Each component has its own state information, and to prevent unnecessary passing of props around the application, Redux separates the state information from the logic. But this all comes at the cost of having to write a fair amount of code to get all the different parts of Redux set up. But it is well worth it for larger applications that need that type of structure. And the final message that we want to leave you with is a quote from the creator of Redux, which says, "I would like to amend this. Don't use Redux until you have problems with vanilla React. So, if you're not sure if you even need Redux, you probably don't need it." Thank you for listening.
Hi everyone, we are here to introduce ASP.NET Core. We will first start off with an overview of what ASP.NET Core is and its features. After that, we will focus our attention specifically on ASP.NET MVC, which utilizes the Model View Controller patterns to develop modern web applications. Finally, we will finish off this presentation by demonstrating a sample application made using this framework. ASP.NET Core is a cross-platform, high-performance, open-source web framework for developing web applications. ASP.NET Core is extremely versatile and contains features such as dependency injection, which we will mention later on in this presentation, and support for hosting remote procedure call services. Furthermore, ASP.NET Core includes tools designed for different scenarios, such as server-side and client-side UI development. As an example, Razor Pages and ASP.NET MVC provides methods to develop web applications for server-side UI. Similarly, Blazor is provided to build client-side UI. As mentioned previously, we will be focusing our presentation mostly on ASP.NET MVC.
ASP has a higher performance. ASP uses the C# language, so that's a compiler-based technology. so it will be much more faster than in the other language. The last thing is the language independent. It will allow developer to choose the language that best applied to their application. And it uses CLR, the common language runtime. So basically you can write some function in this language, C#.NET or C++.NET, and pass the function or the data from the function from this language to other language.
So let's talk about the model view controller. As the name implies, the ASP.NET MVC framework builds web applications using the model view controller design pattern. MVC is an architectural pattern that allows us to separate an application into three main groups of components: the models, views, and controllers. Because of this MVC design pattern, ASP.NET MVC is especially good at achieving separation of concerns. That is, the framework is actually designed to solve the problem of separating user interface logic and business logic. As we have seen in lecture, the models represent the state of the application and should have any business logic. The model will include any logic for persisting the state of the application, including saving to the database. The views are how we present content to our users. Specific to .NET technologies, we can actually utilize the Razor View engine to embed .NET code directly into our HTML. But however, the code that we include into our HTML should be minimal, and the .NET logic in the views and the code should only relate to presenting content to the user. Lastly, the controllers will define the entry points for interacting with the models and how the application should render views. The ASP.NET MVC framework delineates code logic and responsibilities so the application can scale easily as the code complexity grows. From a development perspective, ASP.NET MVC enables developers to abstract logic using interfaces so that other components of the web application don't need to worry about the actual implementation, but can still use their services. Because we can separate logic, we can minimize the impact of our code changes for a model service without having to actually change the logic in every controller whenever we reference that service. ASP.NET MVC is especially useful in practicing test-driven development because our logic written in the framework will be modular. Therefore, this allows us to unit test all of our services defined for a model without having to worry about a controller for end-to-end testing.
As mentioned previously, the view handles the app's data presentation and user interaction. In ASP.NET MVC, this is handled by the Razor View engine, which is responsible for generating the server-side rendered HTML code from the view template. ASP.NET MVC also enables the use of layouts, partial views, and view components to reduce code repetitiveness and increase code reusability. Layouts are useful to provide consistent web page sections such as headers, navigation, menu elements, and footers. Layouts can be specified in one place to reduce the amount of boilerplate markup in the views. Partial views are useful when you want to break down a large markup file into smaller components, or when there is common markup content between different views. They are best used when the content does not require complex render logic or code execution. An example of this is an author biography in a blog website, which may appear multiple times in many different views. On the other hand, if the rendered content requires code to be ran, such as a database interaction, or has complex render logic, then view components can be used. Examples of view components are shopping carts, dynamic navigation menus, and login panels. Here is an example of how to create a view using ASP.NET MVC. First, we let the controller know that we want to return back a view. This is shown on the left figure. The controller can define view data objects, which enables the transfer of data between the controller and the view. In the example shown, we are storing the user's name and address into the view data dictionary. On the right-hand side, we can see the view, which has access to the view data objects defined in the controller. The view then uses a mix of HTML and Razor markup language to render the resulting HTML code. From the view template that was shown previously, we can see the resulting HTML code that gets rendered on the browser. In the background, the Razor view engine transforms the view template into pure HTML code, which is then sent to the client to be rendered.
Let's move on to dependency injection. ASP.NET MVC has built-in support for dependency injection. The purpose of this is to allow our apps easier to maintain and test. One of the architectural principles of ASP.NET is inversion of dependencies. This principle of .NET web applications states that the direction of dependency should be in the direction of abstraction, not implementation details. Inversion of dependencies enforces our classes to have dependencies that are interfaces. Because our dependencies are interfaces, this abstraction allows our code to be modular in that we can swap the actual implementations of the dependencies as needed. As an example, let's look at the inverted dependency graph on the right. Dependency injection allows class A to call methods on an abstraction that class B implements. So this makes it possible for class A to call B at runtime, but for B to depend on an interface controlled by A at compile time. So now this typically would invert the typical compile time dependency, hence the name inverted dependency. As we have seen, ASP.NET MVC framework enables developers to loosely couple applications because of dependency inversion. Ultimately, this means that our applications will be more testable, modular, and maintainable. Dependency injection can also be extended to view files as well when we use the @inject directive, as we can see on this code snippet to the right. Now, for a dependency injection example using our controller. Here is an example of how ASP.NET MVC has very easy built-in support for dependency injection. On the top left, we can define an interface for a service and expose it. On the top right, we implement this service using a class with a concrete adjust sale price method. On the bottom left, we add the service to the service container as a singleton, so there is only one instance of the service for the controller to use. On the bottom right, we inject the service into the controller that will have our concrete adjust price method from the discount service class at runtime.
So I will talk about the benefits of ASP. ASP is a model views controller. They have the controllers, models, and views all separately. So it will be built faster because multiple teams can work on different modules, and the application development will be fast when multiple teams can work on multiple features at the same time. The next thing is it will be easier to develop in ASP. We have the service injection, so there are so many features, so many functions that somebody else already done it for us, and we just need to put them on our application, like the function get count and get complete count. We just need to inject the start service and use that function right away. The next thing is the source code and HTML are together. So you can see here, we put some logic in the HTML file, so it will be easy to write and maintain. So ASP is different with other MVC framework. Like I show you an example here. So in ASP, you can see here we use a for loop inside the HTML. So that would justify the CS HTML. And when you compare it to some other framework like the Django, we have to do it separately. We have to make the logic in the Python file and then pass the data. Like we have to make the render request and pass data to another HTML. And in that HTML, we have to make another for loop and render the list item here. That's a bunch of code, like much more work when you compare to the ASP. You can compare here, like in ASP you like need only 3 or 4 lines of code, while in the Django you have to make like 2 different pages.
Hi, I'm going to show you a demo of ASP.NET MVC. So I already created the demo project. So let me walk you through the application structure. Here you can see there's a various folder. First, this folder called app data, which will store all the database file. Next folder called app star. This contains several classes that will be called when the application is started. Here we have the bundle config. This is where we define bundle. For example, we can combine and compress JavaScript or CSS file into bundle, which will help to reduce number of HTTP requests required when the page is loaded, which will make a lot faster. Next, we have the route config where we define the route in here. So as you can see that there's a default route with this URL pattern. The first part is the control name, second part is the action, third part is the ID. So in this, by default, it will return to the home index URL, and the ID is the optional parameters. Another way to define route is using MVC attribute route, which we firstly call it in here, and then we can define the route later in the controllers itself. I will mention about it later, but let's look at another folder now. Is the content folder, which will store all the CSS images or any other client-side access. And the controller is the C in MVC, where it control all the flow and logic of the application. So in here, I already wrote some of the actions, such as index. So this index action will display the group's information to the users, which has ID, name, and members. And you can see that this controller called groups and this action called index. So if we go to the URL that has groups / index, it will display all the groups information to the users. So in here, I use the view method to rendering the group information out. We also have several methods such as content, which just simply display the content, and HTTP not file, which will return in page not file, redirect, which will take you to another URL. And as I mentioned before, we can define the route inside the controller itself. Here we define the route that have group info and group ID name. Group ID and name is the URL parameters. Next, let's look at the model folder. This is where we define the domain class. Next is the script, is where we store all the JavaScript file. View is contain all the layout that can be shown to the user. So in the share folder and the layout, this layout can be shared between different pages. And let's look at specifically at the groups index layout. In here, you can see that there is a mix of C# and HTML code. So to use C#, we have to put the @ sign at first. So in here, I display the group's ID, name, and members to the users. In here, I also use the for each, which is a C# code to display each member name. Let's look at the next component is the package config, which all the dependencies are managed in here. The next component is web config, is where all the configuration of the application. So to let me show you the actual website. To run the code, we can press Ctrl F5. So in here, I already create the link to this header. So let's look at the groups/index URL. It return the group information, has the ID, name, and each member name using the for each before. And next is the content method, which will just simply display the URL parameters itself. Next is the HTTP not found, which will result in error 404. And last one is the redirect method, which will take you to another URL. So finally, should we learn about ASP.NET MVC? So there are several things that we need to consider about. So first is the time you get to learn about the MVC parents. And secondly is that are you willing to take extra effort and time of splitting up things into pieces? And lastly, do you want to learn about C#? Because we need to know about C# to work in ASP.NET MVC.
All right. Thanks, everybody. Thanks to the 7 groups from this week. Have a good week.